Hello then, and welcome to a brand new video. This is Happy Beyond Numbers, where we learn maths the easy way. We are still on ratio, and in this section, we are looking at equivalent ratio. By the end of it, you'll be able to recognize equivalent ratios, to generate equivalent ratio using multiplication and then division, and then also solve real life problems using equivalent ratios. So let's quickly look into it. So to go into it, it says, what is the ratio? This you see over here, 2 is to 3. What does it mean? You can have so many scenarios to explain what this ratio is. But what if we double it? If we double it, it becomes 4 is to what? 6. My question is, does it represent the same relationship? If it does, let me know in the comment section. If it doesn't also, let me know in the comment section and state the reason why it does or it doesn't. Now, this takes us to what we call equivalent ratio. So when we talk of equivalent ratio, what is it? So equivalent ratio, there are two ratios that express the same relative amount. They express the same what? Relative amount. Let's look at the explanation in this example here. So if I have the ratio 2 is to 3, right? It means 2 portions of a quantity is to 3 portions of that of another quantity, right? Any quantity at all. Now, isn't that the same as 4 portions being apportioned to what? 6 portions? Because if 2 goes with 3, if I double it, I'm going to get what? 4 is to 6. You see? And if I triple this same thing, so I'm going to get 6 is to 9. Right? They all represent the same relative amount. In other words, you can even choose to simplify, or if you simplify 2 is to 3, it still remains as what? Our 2 is to 3. If I choose to simplify 4 is to 6, it becomes what? 2 is to 3. This also, when simplified, becomes 2 is to 3. So the relative amount of comparison is just the same thing, right? Now, with that understood, how do we get what? Equivalent fractions. How do we get equivalent fractions? So we have to find two equivalent fractions, ratio of 3 is to 4, right? So if you want equivalent ratios, how do we go about it? You can choose to multiply or divide, right? So for instance, for the 3 is to 4, I can choose to what? Multiply by what? 2. So if I multiply by 2, then 3 times 2, right? So that is 3 times 2 is to what? 4 times 2. So far as I've multiplied one quantity by 2, I have to do the same to the other quantity. And that gives us a 6 is to what? 8. And we can conclude that what? 6 is to 8 is equivalent to this ratio over here. Do you see? You can multiply by any number of your choice. So if I want to multiply by 5, then I'm going to get 3 times 5 is to what? 4 times 5. And 3 times 5 gives me a 15. So we have 15 is to 4 times 5 gives me a what? A 20. And we would say that what? All these, this one, this, and then this over here, they are all what? Equivalent. They are all what? Equivalent. So with the same preamble, let's find two equivalent ratio for what? 5 is to 10. Apart from multiplying, you can choose to divide as well, right? So this time around, let's divide for one and then multiply for the other. Our ratio was 5 is to 10, right? If you want an equivalent ratio, let's choose to divide by, let me say 5. Now, if we divide by 5, it means we are going to divide 5 by 5, and it is to 10 divided by 5. 5 by 5 gives us a 1, and 10 divided by 5 gives us what? A 2. So 5 is to 10, which is here, is equivalent to what? 1 is to 2, right? we want another equivalent fraction. This time around, let's choose to multiply by 2. So that is 5 times 2 and then 10 times 2. 5 times 2 gives us a 10, and 10 times 2 on the other hand also gives us what? A 20. So 10 is to 20 is also equivalent to what? 1 is to 2, and then it is also equivalent to 5 is to 10. Now let's look at how we'll be able to determine if two ratios are equivalent if we are given. Looking at our questions here, we have to determine whether or not the following pairs are what? Equivalent. Let's start with the very first pair. So we have 6 is to 8, and then 9 is to 12. Now, to determine if two ratios are equivalent, the best way to do is to write them both in their simplest forms. You see, so 6 is to 8 in its simplest form, just as we did earlier on. You divide both the 6 and then the 8 by their highest common factor, and that is what? 2. So 6 divided by 2 gives us a 3, and 8 divided by 2 gives us a 4. You see, the same applies to what we have over here. In the division, you can just write it as fraction. So 9 over 12. And then you say 3 divides 9 how many times? 3. And then into 12 how many times? 4. As you can see, they both give us the same simplest form, right? So it simply implies that what? 6 is to 8 is equivalent to 9 is to 12. Very, very simple. Let's look at the next one. That is 10 is to 15 and 2 is to 3. And we want to find out if they are equivalent. So our 10 is to 15. We know 5 divides 10 how many times? Twice. And it divides 15 thrice as well. For this 2 is to 3 over here, it is already in its simplest form, right? And as you can see, both simplest form are the same. Hence, our 10 over 15 is equivalent to what? 2 over 3. And that is just that. So this is how we determine if two fractions are what? Two ratios are what? Equivalent. The last thing we'll be looking at under this section is the equivalent ratio tables. Okay, so now that we know about equivalent ratios, let's look at what the ratio table is. So as you can see here, the ratio table is a way to organize equivalent ratios in a table format. You see, so if we have this quantity here, I've named quantity 1, and then this here being quantity 2. So if their basic ratio is 2 is to 3, that is this one over here, 2 is to 3. Then if you want more equivalent ratio of these ones, just as with the, we can multiply the 2 by 2, that gives us a 4, you see. Then 3 by 2 also gives us a 6. We have gotten another set of what equivalent ratio here. The same way too, we can multiply the 2 by 3, then 3 by 3. That gives us 6 is to 9. Easy. So this is just the table we have over here, right? And if you want to organize it nicely, you can put lines between them so that it ends up looking like this, right? So that is that. Now, how do we complete these ratio tables? How do we complete them? If you want to complete these ratio tables, first of all, you need to find the pattern, right? Yeah, so if you have the table as this you see over here, you have to what? Find the pattern. What is going on with one quantity? Is it being increased by a factor or it's being reduced? You see, so you try and then identify that pattern. Now, if you identify that pattern for one of the quantities, you apply the same what to both quantities. So as you can see here, it was being multiplied by 2. Here was multiplied by 2. Then we came to multiply by what? 3. And then we also came to multiply by 4. So you are going to do the same to this. That is where we multiply the 3 by 2, giving us 6. The 3 by 3 giving us 9, then by 4 giving us 12. You see? Then if there are any missing entries, you do what? You fill it based on the pattern you have what? Observed, right? So in view of that, I'll be writing out some tables which would try and then fill them out. So let's look at this example here. It says you have to complete the ratio table here. And over here we have apples and what? Oranges. We have apples and oranges in a table. Now we are looking for what the value of A is and also the value of B. So we know the basic ratio is what? 3:5. And ratio tables are built on what? Equivalent ratios. So if here from 3 we all of a sudden came to what? 6. What happened? How do you obtain 6 from 3? We do that by multiplying what? By 2. So that should tell you that if you want your A, then you have to multiply 5 also by what? 2. That is what it means. You should apply the same operations on what? Both quantities. So on this quantity, it was multiplied by 2. Hence, we have to do the same thing over here. That simply means that our A is going to give us what? A 5 by 2. And 5 by 2 gives us what? A 10. So A is 10. You see? Then we still look at the operation that made us get what? 9 from 3. If you look at it carefully, you realize that you have to multiply 3 by what? 3 to give you this 9 over here. So to obtain whatever it is at this B, then we have to multiply what? The 5 also by 3. So that the same thing would be done again, right? So that is 5 times 3, which gives us what? A 15. You see? So it simply means that our A is what? 10, and then your B is 15, right? So basically, this is how we apply the idea of equivalent ratios to complete our ratio tables. Now, in view of that, I would leave some try works here you can do on your own. This is on the basic ratio. Then this is on using the ratio language. And then this here, you'd complete the tables using what we've just learned. See you in our next video where we do an introduction on proportion, then understand how relate ratio to proportion to solve practical and then challenging problems. See you in our next video and stay safe. Bye.